Good morning, everybody. We will wait the obligatory minute to give all participants the chance to dial in. So stay tuned. So welcome to today's tech session, Exoscale going further with Kubernetes, SKS, the Scalable Kubernetes service. My name is Benjamin Sternberg. I would like to start by giving you some information about the online session. Since the webinar is recorded, all participants are muted. If you have questions during the presentation, you can write them in the chat window. I will collect the questions and ask those questions in the Q&A sessions for you to the speakers. As a follow-up, you will receive on Monday during the day the following content by mail: the assets of the presentations, the recording of the webinar, contact options, and other links that might be of interest for you. So let's get the show started. Welcome to the tech session, Exoscale, going further with Kubernetes SKS, the Scalable Kubernetes service. I'm very happy that we were able to attract such a large number of participants for the session. We have prepared some exciting topics for you. After the intro and overview by COO and co-founder Antoine Coessier, we get into the topics continuous deployment with scalable Kubernetes service, including a live demo with ArgoCD presented by my valued colleague Wouter Dulert. After that, Dennis Arnst will show block storage with ease on Exoscale, SKS, a Longhorn use case. Finally, we will answer your questions in a joint Q&A session. I would like to hand over to COO and co-founder Antoine Coessier, who oversees the business and operational aspects of the Exoscale platform with his 20 years of experience in the service provider business. I hope you enjoy the online session. The stage is yours, Antoine.
Hello, everyone, and great to be back today. Today is a continuation on the first announcement we did on February 16th. It was the announcement of the limited availability of SKS, and today we are particularly proud of being able to have reached a milestone and be able to communicate that general availability target is scheduled for April 1st. So that's not an April Fool's joke. And a recap on the versions. So as a reminder, what we presented last time, we are coming to the market with two versions. So starter version and pro version. Starter is really to be able to use Kubernetes and embed Kubernetes in your pipeline. Make sure that you can spin clusters really easily. Whereas the main distinction with the pro version is that it brings high availability of the control plane and also full supportability and SLA by our top teams of support. Of course, both versions, they have absolutely no overcharge on any of the running nodes that are attached to the clusters. So that's the product layout we have. So what does general availability means? This means, if you can switch to the next slide, please. Thanks. General availability means that we've reached deployment in all zones. So we've moved progressively from February 16th, we had 3 zones available. Now it's fully deployed in all zones. We are also going to open the web portal user interface. So everything we've been showing and doing from the CLI or from the API is also possible with the portal. You'll have some previews today, and we have done some meetups also, where now there's videos around with previews of the portal. Of course, we're going to release the extended documentation on how to use the various commands and how to proceed with SKS operations. What does it mean also is that for the Pro version, we will fully activate and endorse our SLAs starting April. So, I mean, this means that any production workload is fully eligible for use on SKS, and so associated with the Pro version, the billing will start. What's new since the initial announcement? So we've released several improvements already. One of the first is lifecycle management. You know that Kubernetes is a fast-moving ecosystem, so you need to keep your Kubernetes cluster up to date and be able to cycle to the versions. So there's full support for that now within SKS. We also have additional support to manage credentials and do certificate rotation, and we also released the full Terraform support in our official Exoscale provider. What's next for us? We're shooting for in the next quarter for obtaining the CNCF official conformance for SKS, which will make sure that SKS respects, I mean, all what the CNCF community defines as a fully compatible Kubernetes service. And we will also be launching first trainings about Kubernetes and SKS and an associated certification. So maybe especially interesting for our partner, for our Exoscale official partners. So that's it for the marketing and the updates regarding Kubernetes at Exoscale. What we have prepared today is really two very technical talks, interesting talks, and I hope for you we'll start with Wouter talking about continuous deployment. Wouter, on to you. Thank you.
Hello, everybody. My name is Wouter de Laat, and I will be walking you through SKS using Terraform. And then in a second part, we'll take a look at ArgoCD to look at how you can do some continuous delivery onto your fancy new SKS cluster. I am mostly a terminal person, so we're going to look at a terminal for quite a while, but I'll be showing some dashboards as well, which should make it visually a bit more interesting. So given that I have a lot of content, I'm going to jump straight in, and I hope I can make it to the end before my time runs out. So the first thing that we want to do is we want to create an SKS cluster using Terraform, which is my favorite tool to create cloud infrastructure. So I've prepared a few manifests, and I'll walk you through it in a second. So if we look at sort of the files that we have in here, I will remove this one because I'm going to recreate it. So the first thing I'm going to show is the provider file. Is this visible enough for everybody? I hope so. So basically, in the provider file, I'm going to open it in Vim because this one is readable. There we go. We basically say that we want the Exoscale provider, which are these lines, and we want a very recent version because otherwise we will not have support for SKS. And here we configure the Exoscale provider. So basically we don't put any configuration in here because we are going to load all of our secrets from the environment. which I'm going to do like this. Once we've configured our provider, we need to tell Terraform to actually fetch it, which is what you do with Terraform init, because all the providers are a form of plugin. So when we run Terraform init, Terraform will take a look at which providers you want to use, will download them for you, and set them up properly. So now I have a working version of the Exoscale provider on my machine. So let's take a look at the actual interesting resources, which is the SKS cluster. So we'll start from the top over here. I'm defining a variable which is called a local inside in Terraform speak, mainly just to define my zone. So we will be deploying this SKS cluster in the Frankfurt zone. So this prevents me from having to type it over and over again. And then the first resource that I'm defining is my SKS control plane. So I'm going to make a cluster called demo. I'm going to deploy it in Frankfurt. We're going to use Kubernetes version 1.20.5, which is the latest one as of right now, I believe. I can give it a description. We will be using the pro level because having some redundancy on our control plane is always nice. And then the last two lines are some additional features that you can install. So the first one is a CNI, which is a networking plugin. And we are going to install Calico. I think the majority of people will want to use the networking plugin that we provide. But if you have very specific networking needs, or you have some very strong preference for other networking plugins, you can install your own if you want to. Keep in mind though that without a networking plugin, you will not have functioning network and you will not have a working cluster. And then as a last thing, we will also install the Exoscale Cloud Controller. So this installs the CCM, as it's often referred to, which allows Kubernetes to integrate with the Exoscale platform. So very specifically, this allows us to provision networking load balancers automatically from Kubernetes when we make a load balancer service. And this will be installed in the control plane itself. And that's the meat of it. So this gives us the control plane, but we also want a few nodes that we can schedule our workloads on, and these are defined a bit lower. So with SKS, we have a concept of node pools, which is a specific version of our instance pools. And so that's a set of homogeneous machines. But if we use a node pool, we will also automatically inject the necessary credentials so that it can join your Kubernetes cluster. And so that's what we will be doing with this node pool resource. So we're saying, okay, deploy it in my same zone, but then make it a node pool for this specific cluster. So this is the magic thing that will make sure that that these machines get the necessary credentials to join our Kubernetes cluster. We give it a name. We give it a size, so this will create VMs of the medium type, and then we will make it of size 3. So we will get 3 nodes. And then as a last thing, we will also assign a specific security group to these nodes, and I'll get to that in a second. So with this resource, we will get 3 nodes that are part of our cluster to which we can schedule some workloads. So the final part that we have to do is set up a security group. Because this is something we aim to improve in the future, but for now you have to manually set up a few rules in the security group to get to be able to use all of the features. And I'll go through them quickly one by one. So we need one rule in our security group to be able to pull logs using kubectl logs. And so this opens this particular port towards the internet. If you have another way of getting to your logs, you may not need this, but for the purpose of this demo, we are going to add it anyway. The next rule that we need is due to the fact that we're using Calico. So Calico requires that all the worker nodes can communicate over UDP with one another. And that's what we're doing with this node. So we're basically saying we open up port 4789 over UDP to all the instances which are actually in this security group. So this doesn't open anything publicly. And then the final rule is necessary because of the Exoscale Cloud Controller Manager, and this opens up a bunch of TCP ports towards the internet, because these are because the Cloud Controller Manager will randomly select a port within this range so that a networking load balancer can talk to your nodes automatically. These are also documented in our quick start guide, and there are or should be part of our examples in the Terraform provider documentation, so that you have a reference to find them. So with all that said, let's actually do something. So the first thing we're going to do is we're going to do a Terraform plan to sort of see the changes that Terraform is going to make to our infrastructure. So if I run this and I wait half a second, it will tell me that Terraform plan will try to add 6 resources. And if all goes well, we should see the resources that we've just gone over in this list. So I'll scroll up a bit. There we go. So we can see that it will make our security group. We can see that it will make the Calico rule. We see that it makes the Cloud Control Manager rule and our kubectl logs rule. We see that it makes our cluster, and we see that it makes our node pool. So that's fine. These are the changes that we expect to our infrastructure. So we can now apply these. All right. There we go. It will do a plan again. I need to confirm that I want to make these changes, and off it goes. So if this were another cloud provider who shall remain unnamed, we can now stop the webinar and come back tomorrow to look at our resources. Fortunately for us, SKS provisions quite a bit faster, and I will only have to talk for about 2 minutes before I have a functioning Kubernetes cluster. Unfortunately, I don't have a whole lot to say. So I'll quickly cast my view into the future. So what we will be doing next is we will be pulling a kubectl config file for our Kubernetes cluster so we can interact with it. We do not provide this the kubectl config file as an output to the SKS cluster resource in Terraform, because this would mean that the config file will be part of your Terraform state. And since this config file contains some secrets, we would rather not have them be in plain text in your Terraform state file. So what I've done instead is I've put an output to my Terraform workspace, which will be the exocli command that you can run to download a kubectl config file. You can also download the kubectl config file from the portal, which I will show in a second. And then once we have our kubectl config file, we can start looking at our cluster and see the nodes and start provisioning workloads. And that should be any minute now. So a few more seconds. There we go. So just shy under 2 minutes, and we have our cluster. We still need to create the node pool, but that typically goes a bit faster. There we go. So as you can see, the output of my workspace is the kubectl command. So this will invoke the Exoscale CLI, so exo SKS kube config, for my particular cluster ID, which I've dynamically retrieved from my Terraform workspace. I'll show you quickly in the Terraform file how that goes. Oh, that's not what I wanted. And then we basically make a make a user, say which zone it is, and make ourselves the administrator of the cluster. So if we quickly look back into our SKS cluster, the output is defined here at the bottom. So that's this stanza. This repository will be public, so you will be able to see this for yourself. But that kind of makes it easy, because otherwise I would need to first go take a look at where and how do you quit Vim, right? Let's just quit. There we go. So if I now copy paste this, there we go. Control C, Control V, and I'm going to put this in the kubeconfig.yaml file. There we are. So wait a few seconds. I'll just to show that there's a whole bunch of stuff in there, and then yes, this is a functioning kubeconfig.yaml file. It's not particularly interesting. And now I'm going to play a small trick, which is I'm going to export this. So kubeconfig is the current working directory / kubeconfig.yaml. And so kubectl will basically pick up your kubeconfig file from this environment variable. So by exporting this, I don't have to keep typing it, and I can move to any folder and still be connected to my cluster. So let's take a look at our cluster. So we're going to do kubectl get nodes. And there we are. So we are connected to our cluster. We can see that it has the version that we wanted, and we can see that our node pool has created 3 nodes, but they're still not in the ready state. So this means that the Calico networking plugin is still provisioning on them. So that gives me a bit of time to quickly look into the console, and I will refresh, or it refreshes on its own. And so we can see that, yes, these 3 SKS nodes have been created over here. And if I go to the SKS subsection, I have a demo cluster. And if I click on that over here, I can see that it's running and all is well. And if I go over here, I can get some options. And so I can download my kubeconfig file over here as well, or do some other administrative actions on my cluster, such as adding a node pool or rotating my like the IAM key that's being used by the Cloud Manager plugin. So that's the Terraform part of the presentation. So normally my nodes should be ready, and there we go. And I have 3 working nodes that I can schedule workloads in. I will need to go a bit faster. So I'm now going to go to the Kubernetes folder, and the first thing I'm going to do is I'm going to provision some what I like to call quality of life workloads. So the first thing, because before we can get to ArgoCD, I would like to show you the dashboard, which means that we will need some way to access services running inside of the cluster. So generally, this means that you need to deploy an ingress, which is a load balancer to expose HTTP services. And because I'm kind of like a stickler for detail, I'm also going to provision something which gets a valid certificate, because in these time and days we should be using HTTPS. And I'm also going to, because I need a certificate, which means that I need a decent host name to go with the certificate. So I'm also going to deploy something that manages DNS. So the first thing is my certificate. So I'm just going to kubectl apply -f lego. Oh, I need one more space. There we go. And so what this thing will do is it will create a cron job that tries to get a wildcard certificate from Let's Encrypt. And so this will run daily, and it will check whether the secret has expired or not, and whether the certificate is close to expiring. And a few days before it expires, it will renew it, and it will put it into a secret inside of the Kubernetes cluster. So if we quickly look in the traffic, namespace get secret. There we go. So we can see that my certificate has been provisioned over here. Like this is a small tool that I've written myself. If you have much, because for the purposes of this demo, a single wildcard certificate is enough. And so I just wanted something simple that got that done. So I have this tool. If you have much more complicated certificate needs, I recommend that you take a look at Cert Manager, which can do a whole lot more, is much more configurable, but it's also more complicated to run. So there's a trade-off over there. The next thing I'm going to deploy is my ingress. I'm going to spend a bit more time over here because I think most people will want to deploy an ingress. And so I'll do traffic.yaml. So I've chosen traffic as the ingress controller because it's purposely built to be an edge proxy. You have numerous options for an ingress controller. You can use nginx, which we at Exoscale also extensively use. There's things like Ambassador. There's a long list of ingress controllers you can use, but I happen to like this one. And so an ingress controller is really just another Kubernetes service which is running. And so the first thing that we're making here, and this is based, so traffic has a Helm chart, but I kind of chose to deploy it the hard way with a YAML file. So the first thing that I'll be showing that we need to create is a deployment. So the deployment is essentially sort of an auto-scaling set of pods, and pods are the basic unit of work that a Kubernetes cluster concerns itself about. So in this case, we want to create a traffic deployment, which is it's just the name. Since this is sort of an auto-scaling set, we need to give it a strategy for what needs to happen if we update it. And so we say, okay, we want to do a rolling update one by one. So this means that if I have 3 replicas of this particular pod running, it will always restart them one by one, so I can remain, so my service remains available. And then we need to give it a pod template. So this is basically the description of the pod that the deployment needs to create for us. We put on some labels. It's not super interesting, so some metadata. We give it a specific service account name. This is necessary because traffic is an ingress controller, which means that it needs to talk to the Kubernetes API to find out which ingress objects you have created. And so that means that I need to give it some permissions inside of my cluster, and those permissions are assigned to a service account, and I need to tell the deployment to use that service account. And then I need to say which container it needs to spawn, so it needs to use the traffic image. I always want to pull it, so I can easily get updates, some health checks, and then this is where it's more interesting. So we kind of need to say which ports this exposes. So it's going to expose a port on 8080, which is for the health checks and internal, which we will not be exposing outside of the cluster. We will have a port named web, which is on the container on port 8000. This will serve HTTP traffic. We will have a port called web secure, which will serve our HTTPS traffic. And then we have a bunch of volume mounts. So I need to give it a writable temporary folder. I am mounting a configuration file, which I'll show in a minute. And I'm mounting the Let's Encrypt certificate that I created earlier. Then I have a bunch of arguments. So I'm basically saying, please expose a port on 8000, please expose a port on 844. So this exposes my HTTP and HTTPS ports. Serve the dashboards, have enable ping for the health check, use this particular config file, and then this is the interesting part, is like do work as a Kubernetes ingress. So I'm saying like, yes, you need to get your configuration from the ingress documents, and then this one is just a standard stands up for traffic to redirect HTTP to HTTPS always. So I just have to do this once. And this tells it to use TLS on the web secure endpoint. And that's pretty much it. The one thing that I need to put in a config file, which I can't specify as arguments, is the TLS configuration over here. So this basically says mount my certificate and use it for all connections. And because I have a wildcard, that is fine. And then the last thing over here is the service definition. So a service is basically a DNS entry inside of your Kubernetes DNS support. So it basically gives a name to these pods. So we want to create a service of name traffic, which should front the pods that were created by the traffic deployment that we did earlier. And then we put a very specific type on it. So you have various types, but the one that we've chosen here is type load balancer. And type load balancer causes our cloud controller manager to provision an Exoscale NLB, which does not live in your cluster. And so this NLB will automatically be connected to your Kubernetes service. So this allows traffic from outside the Kubernetes to talk with the service inside of Kubernetes, which is exactly what we want for the ingress. And there's not much you have to do. So you basically specify the port mappings over here inside of your Kubernetes service, and our NLB will pick that up automatically for you. So what we're telling is we want port 80 on our network load balancer to be mapped to the web port of the traffic service. And we want port 443 of our network load balancer to be mapped to the web secure port of our traffic deployment. And this will, like I said, Kubernetes, our cloud controller manager will pick this up and it will create the Exoscale resources for you and configure them for you automatically. You don't have to do anything else. And then below here, the ingress class is just an additional piece of metadata I need to give Kubernetes to make the ingress work. So let's go ahead and basically apply this. So kubectl apply -af ingress. There we go. And if I now basically take a look in the traffic namespace, add how many pods? Oh, no resources found. Did I put them in the wrong namespace? Let's just, this is why demos are so fun. Let me quickly check again. Do I have, there we go. I need to tell it to put it in the traffic namespace. So we're going to kubectl delete -af. So, and this is why Kubernetes is kind of nice. Just like that, I can also remove resources from my cluster. Unfortunately, it takes a small second for it to properly propagate. So I actually, for the certificate, I had hard-coded the namespace in the manifests, but for the ingress, I hadn't, which means that I needed to tell kubectl the namespace that I wanted to put this in. And unfortunately, there we go. So what I had to do is tell it to put it in the traffic namespace, these manifests. Apply. There we go. And now I should be able to see my pods being created. So we are creating our ingress. And if I do get service, that's also nice. So we can see that we've created the load balancer service named traffic. It is exposed on this IP inside of the cluster, and we are still creating our network load balancer, so the external IP is pending with a bit of luck. Not yet. So before that, then I'm just also -n external DNS. I'm going to quickly create the other thing that I want to have. I won't go over this in detail because I am running out of time. There we go. So this external DNS will create DNS entries in my DNS provider based on service definitions and ingress definitions in Kubernetes. So this means that if I create an ingress for a particular host name, external DNS will actually ensure that that host name is mapped to the NLB IP address of my ingress. And that's really nice because it means that all you have to do to expose a service to the outside world is create your Kubernetes manifests, and you will automatically be exposed on the internet. You will get a DNS entry and you will get a certificate without having to do anything else. So, which is extremely good for developer velocity. I just want to point out over here as well, there was a bit of a race condition because I hadn't created my external DNS namespace yet. So when trying to create one of the resources, it didn't find the namespace yet, so it errored out. But that, again, is not really an issue because Kubernetes is declarative. So if it fails, I can just try it again. And if the resource already existed, it will just say unchanged. I had to do nothing. And then it will just apply the changes as necessary. So this is a very fail-safe way of deploying resources. So let's take a look again at our service, traffic, get service, and that should be up by now. There we go. So this is the IP of my network load balancer. And to prove this, so I can show this to you in the Parker. And you can see that this is the same IP. And because I've also deployed, no, actually. So now we can actually get to ArgoCD. And I'm just going to kubectl, apply that again. And ArgoCD apply. There we go. No, this is not going to work. There, I need to use customize. Customize. I've used a different build. I don't remember. This is a problem. I prepared this demo on a other machine, so this shouldn't take long. There we go. So customize is another, there are various manifest creation tools for Kubernetes. So you can create raw YAML files, but that gets verbose quite quickly. And customize is another one which is promoted by the Kubernetes team. So customize build, I think, this folder, yes. There we go. So that should spit out a whole bunch of manifests on the terminal, and then we basically pipe these into kubectl apply to get them into our cluster. And you will see that a whole lot of resources are created. The reason I used customize to deploy ArgoCD is because the ArgoCD upstream maintains customized manifests, which means that I can just point to their manifests, which I know will be fine, and just apply the changes that I need for my configuration. All right. Oops, and then ArgoCD, get pods, and we can see that everything is starting up. So this allows me to talk a bit about ArgoCD. So ArgoCD is a continuous delivery tool. And what it does is it will watch Git repositories that contain Kubernetes manifests and apply these in a cluster that it's managing. And you can configure how automatic it will apply these. But if you put on all the bells and whistles, when you push a change to your Kubernetes manifests into Git, ArgoCD can apply these automatically onto your cluster. And but depending on your risk profile, you can also, require manual approval before this happens. So, all right, most of it is up and running. So I'll just go ahead and show you. So we should There we go. So this is the ArgoCD instance that I have just deployed. And as you can see, it's using full HTTPS, and I automatically received the host name, which was in the ingress manifests. So one thing that I have done in these manifests, which you should not do at home, is I have given the anonymous user admin access. So you don't need to log in, you can do anything. This, of course, has a side effect that anybody on the internet who knows this URL has admin access over your cluster, which is not what you want, but is very convenient for this demo. So, like I said, ArgoCD takes, and I'm going over my time. So ArgoCD takes a Git repository with manifests and applies them in your cluster. And so it does this with a concept of applications. So each application is a subfolder in a Git repo that it needs to apply. And you can create these in the dashboard. So I will make an application. I will call it demo. We will put it in the default project. So projects allow you to perform access control, which can be useful in a multi-tenant environment. For the purpose of this demo, we just have the default project. We will ask for manual sync. The other options are automatic. So this is what I explained. If you put this to automatic, any change in Git will automatically be applied on your cluster. If you put it to manual, an operator will have to push a button and can first, just like with Terraform, first inspect the changes that are going to be made on your cluster. We're going to tell it to auto-create the namespace for us in case it doesn't exist anymore. And then we're going to point it to our repository over here. So we will point it to github.com, exoscale / SKS ArgoCD.git. There we go. It can pull off of master, and it should pull. So ArgoCD in the background has already pulled my Git repository and knows about my folder structure. So it found an ArgoCD app with customize, and it found my demo app. So I'm going to do my demo app. Then we need to tell it where to deploy. So we want to deploy in the current cluster. I'm not really sure which namespace I took. So demo, there we go. That's it. And then we say create. And if all goes well, I get my app. If I take a look at that. So ArgoCD has found my folder, and I'll show you in a second over here. So if we go to that actual folder, which is demo, it found these resources and expanded them for us. And so it says, like, I have a demo app, and your manifests contain a service, it contains a deployment, and it contains an ingress. And then we can inspect what it will try to make. So it says, like, I'm going to add a manifest with this, going to add a manifest with this, and I'm going to add a manifest with this. So if the operator has taken a look at this and he's happy with those changes, then you can say sync, synchronize, off we go. And ArgoCD will now go ahead and create all of these resources in my cluster. But as you can see, like, it creates my deployment, and the deployment, as I mentioned before, is responsible for creating pods. So you can see that it made the pod. You can see that the pod is passing the health check, etc. It created an ingress, and we can take a look. So we can actually, I'll need to scroll down a bit like this, look at the manifest inside of the cluster as it exists right now. If you really want to, there's a big edit button here at the top, so we can even in place update these manifests. The reason I'm showing this one is because I've asked for the app to be available on this domain. And if I go there right now, well, we see that the app is deployed. It's a Who Am I app, so it basically is kind of like HTTP echo. And that will automatically deploy. And it's running for us. So what we can do next is we're going to update that manifest. So over here, this is the manifest for my deployment. And so I'm just going to change the container that it needs to run. So we had this Who Am I app running. If I change that, there we go. I'm going to just make that the basic nginx. There we are. So we do git status just to confirm that this is all that we want to update. We just want to add demo.yaml. We say deploy nginx as demo. And I push this to GitHub. There we are. So now we can go back to ArgoCD, and ArgoCD polls GitHub regularly for updates. But because I'm the impatient type, I'm going to actually ask it to refresh right now. And as you can see, it found the change in Git, and it's going to tell us your app is still there, but you're out of sync with the state that's being requested by Git. And you can see which resource is out of state even, because it'll show this nice yellow icon over here that the deployment is out of sync right now, which makes sense because that's the only thing that we touched. We can again ask for the application diff. And there's a cool one here. So we do compact diff, which will remove all of the other stuff. And we can see that, yes, the image has changed to nginx. This is the change that we expected. So off we go. We close this one over here and we ask it to sync again. Synchronize. We are. So we can see that it applied the change. Our new pod is starting. This could take a while because it needs to download the image. There we are. And you can also see that it actually first starts the new one, waits until it's healthy, and only then stops the old pod. So this means that if for some reason your new pod cannot start because you made a configuration change, you can't pull the image yet, or something else is wrong with it, the old ones will still be there, so you will not have downtime on your service. So everything's deployed right now. So what I need to do here, if I refresh, there we are. I now get the nginx welcome page. My app was updated. There we go. I had a few more things for ArgoCD to show that these applications are actual Kubernetes resources, which means that maybe I'll just still show that. Since these are actual Kubernetes resources, we can create them. We can actually create them using kubectl. So what I can do is I can do kubectl-n ArgoCD apply-f ArgoCD.yaml. There we go. And boom, my application is created over here. So, and this is another fun one, which is because ArgoCD already existed, ArgoCD is actually discovering the resources inside of the cluster. So this is really nice for bootstrapping, as I've just done, because I can bootstrap my cluster using kubectl apply and then make ArgoCD aware of the resources that already exist. And if you take a look at the app diff over here, this is just a bunch of metadata. So ArgoCD is just adding labels left and right, but it's not going to be touching anything else. And so since labels can be updated in place, if I do my sync right now, this will actually not even restart any single pod. My ArgoCD instance will just keep running. And so this ArgoCD instance that I created with kubectl can now be managed by ArgoCD. So this without any downtime, without any risk to your deployment. So this is super nice. And then the other fun thing about this is you can manage ArgoCD with itself. And then the final trick, I'm just going to show this and I'm going to hand over to Dennis because I'm eating his time, is because these are resources, Kubernetes resources, we can actually create ArgoCD applications with ArgoCD from an application. So if I go one up, that's what this one is doing. So I have this root application, and this root application is responsible for creating other applications, which are then responsible for creating all my services. So if we do this, kubectl apply -f. I need to put it in the right namespace, ArgoCD f root application. And I need to tell it that we actually want to apply. So this pattern is called the app of apps. And as you can see, so the root application all of a sudden appeared, and because I enabled automatic sync for this, right? So I've enabled automatic sync. It automatically created all the other applications that needed to be, that I've made it aware of. So it automatically created my Lego application. It automatically created my Ingress application. And so these applications here, they are pointing at the same resources that I've created before. And so ArgoCD discovered them and synced them. And so now with this trick, you can build a very, very powerful continuous delivery pipeline where everything is managed through changes in Git, even the configuration of ArgoCD itself. And for each of these applications, depending on how critical they are or how stable your manifests are, you can decide whether you want them to automatically sync or not. And so that kind of concludes my demo. I hope it was useful to all of you. Like I said, these manifests are all available inside of Git. I will put a few more comments in there where I made some shortcuts that you should not do in production, but they should provide a good starting point if you want to try this out for yourself. And with that, I will hand the floor to Dennis. And I'm so sorry for eating so much of your time.
So hello, very nice presentation, Wouter. But we will now directly start with storage. And I will first show you some theoretical things before we directly dive in. So here you see a Kubernetes cluster, and you see, okay, we have virtual machines. These are real Exoscale virtual machines. And on top of that, we have the Kubernetes nodes. So in this case, 3 nodes and the pods and containers. So this part is practically managed by Exoscale. You get a cluster, and then you can directly deploy your application. But what if you want to deploy a database, for example? Then you need some kind of storage. And of course, as these are real virtual machines, we can just use the local storage of this virtual machine. So that means when I use something like MariaDB or MySQL, I will just use the disk. However, this may be a bit bad because, well, what happens if this node, for example, fails? What happens with my storage then? So on Exoscale, it's like that. When a node fails and you have 3 nodes, then Exoscale will notice, okay, one node failed, I will boot up another node. And Kubernetes will see, okay, there's a new node. So let's schedule this container, which we had here before, to this new node. However, we use the local storage of the disk. So of course, the data is gone. There's no magic. So if I use the local storage and this node fails, then the data is gone. And this is basically bad. So local storage should only be used when you have temporary data, for example, or some kind of caching. But what do you use when you have a database? Then the magic word is actually block storage. Longhorn is a software for block storage. So you can just deploy it on your cluster. It's really just copy and pasting one comment, and then you have to wait 3 minutes, and then it's ready. And Longhorn sees all the nodes in the cluster automatically. And then you can say, okay, Longhorn, please give me a volume. And this volume is then replicated on different nodes. And as such, when, for example, this node fails, then Kubernetes will reschedule this pod to another node, and this pod can then still access the data, even when it's on this node where the volume isn't. And this is the real cool thing about Longhorn. In the end, of course, Longhorn will use the local storage, but it will replicate the data. So I've installed Longhorn beforehand, and this is how it looks like when you freshly install it. Like I said, it's really just one comment, and then you are ready to go. And here we see some data. So we see, of course, we have no volumes yet. I didn't create volumes. We have storage ready. So like I said, Longhorn sees out of the box all nodes, and also, of course, sees the storage of those nodes and makes this storage, which is available in the nodes, of course, available to you. Also, we see the amount of nodes, and below some event logs. So here is the list of nodes. So no surprises, of course, 3 nodes, and we see the storage. And here is the volume tab. So we have no volumes, but we can create one. So we can just call it my cool volume and specify a size. We can also specify the amount of replicas. So I want high availability, so I use at least 3, maybe 4. And we can also specify some other things. For example, data locality. Data locality is actually for performance. So you can say, okay, when I schedule a pod here and it needs a volume, then this volume should also be on this node. This is data locality. So that means I have more performance in the end if I enable this one. Also, there's different access modes. I will explain that later. And we also have tags, and tags are for that. For example, you want to schedule a volume on a specific node or only on specific node pools like storage optimized nodes. So creating it was kind of easy. We also see it's ready. It's detached because no pod is attached. But this method of creating a volume is actually not the usual way to go. So let's delete it again. Instead, I will show you how you can create a volume automatically inside a manifest, inside a Kubernetes manifest. So when we want to use volumes, we usually use a persistent volume claim. A persistent volume claim, a PVC, is just like a pod, but the difference is a pod requests CPU and RAM, and a persistent volume claim requests storage instead. So that means we are requesting storage. We will also give the request a name. We will also specify access mode, so you saw it before. And read write once means that one volume can only be attached to one pod. And this is the most performant solution. You could also specify read write many. And that would mean you can attach multiple pods to one volume, so the volume is actually shared. But this always comes with a performance impact, and read write once is actually the way to go if you want to use a database. Then you specify a storage class name. You can just use Longhorn, then it will use Longhorn and the default values of that. But you can also customize it and say something like, yeah, you need 4 replicas, and I want to have backups, and I want backups automatically at 3 a.m. in the night, and so on. So you can completely customize your things here. Also, of course, I'm saying, okay, please give me 2 GB of RAM. Then this is the pod. So like I said, a pod requests CPU and RAM, and this is usually bound to a container. So here I'm creating an Ubuntu container. It will just idle around so I can use some cool comments later. Also, we have a volume mount. So that says, okay, here we actually at volumes link the persistent volume claim. So here I'm using the same name as above. This will link it using the same name. And then I'm saying, use this volume here on volume mounts and mount it on /data. And this is what this manifest does. So let's check it out. Or yeah, make it this just like this. And now it's getting applied. We can also take a look on Longhorn, and we see this automatically actually created a volume here on Longhorn, so fully automatic. And now what I can do is I can go into this pod. So let's check the pod. This is the pod. It's still creating. So let's wait a bit. Now it's running. And now I can go into this pod and run bash there, so we're inside the pod. I can list the file systems available, and here we see, okay, we actually mounted something on /data, and it's a Longhorn volume. And we can also go into /data, list it, and then we see, okay, we have an empty ext4 file system, and we can now use it to write some data into it. For example, echo hello from pod. And now we've written into this Longhorn storage. So let's exit it again. And let's kill the pod. So this takes a bit of time. And of course, I have to write it correctly. And let me just check again. Okay. Maybe I'm in the wrong namespace actually, but this doesn't matter so much. So here we see actually all pods, and we see, okay, it's the example pod. And let's just specify the namespace. Okay. Now it gets deleted. And what is happening there, it takes a bit of time because it's actually detaching the volume. So when I'm deleting the pod, it doesn't delete the volume behind it. So we created a persistent volume claim, and of course there's persistent in the name, and that means the volume will stay even if you delete the pod, even if the node gets killed where the pod is on, and so on. So it is getting deleted, and we can also take a look on Longhorn, and we see then, okay, the volume is getting detached, so that means there is no pod attached anymore. So I've also prepared a second manifest, and this is actually the mainly same pod, but it has a different name. So I called it in this case pod second. But the important thing is it uses a persistent volume claim. It doesn't create one, but it uses one, and it uses one with the same name. So let's apply that. So it's called 2. And now the pod gets created. And we see on the left side, okay, the volume is actually getting attached right now. So let's wait a bit until the container is ready. And let's go again now into this container. Now we see again that something is attached on /data, and we can actually see, okay, it's the same data which I have written before, and this is now available. And this is the cool thing. So you can just take volumes, attach them to some pods, and deattach them, of course, and then use them somewhere else. Let's click on the volumes again. So here we are, and let's go into this volume. So here we see the replicas. So we see, okay, it's replicated on 3 different nodes. Okay, no surprises. And we can also do more cool things. So for example, we can take a snapshot. But I think the best feature is the backup feature. So let me just show you the Exoscale console. And Exoscale has something called storage buckets. There you can simply store data like static files and so on. And those storage buckets don't have anything to do with Kubernetes. So we could create one, for example, in Frankfurt, and my Kubernetes cluster could be in Vienna. But I've created and configured one beforehand, and this is this bucket. And this is still empty. So let's create a backup. We can also add labels. And then let's see what happens here. And we see, okay, there's a new folder created. And there, this volume is actually backupped. So you can use this feature on Longhorn to store your volume on complete different infrastructure. And this is the cool thing. And the real cool thing is that it works out of the box. So you just configure your storage bucket. You just say where it is, and then it will work. Also, if your whole cluster fails, then you can theoretically install Longhorn again and configure this bucket, and you will see your old data still available. And you can use this data to actually restore your pods or to actually provide disaster recovery. And everything there is actually, like I said, quite easy to use. You will get a GitHub repository, a link to it, where I have some examples and where it shows you how to install Longhorn. It's really just copy pasting this one comment. And then you are basically ready to go. Also, I have one further example, and let me quickly apply that. So let's exit it again and apply this stateful set YAML. So let's go back on volumes here and take a look at the manifest. So this is basically also the Ubuntu container, but the difference is that I specified 3 replicas with a stateful set. And that means the Ubuntu container gets booted up 3 times. And as this is a stateful set, each of these pods, so each of these 3 pods, get its own volume actually. So let's take a look into the console. So we see there's a database 0 created, a database 1 created. We can also refresh it. It takes a bit of time because it's sequential. And when this is then finally created, okay, right now, we also see a database 2. And we can take a look at the persistent volume claims. And then we see, okay, it created a volume for database 0, for database 1, and for database 2. And also, of course, we see it in the background. And stateful sets are perfect for databases. That's also the reason I named it this way. So basically, database 0 will always get volume 0. That means even if the node gets killed where database 0 is, then Kubernetes will create a pod named database 0 again and configure it, and then will attach the volume 0 and not volume 1 or volume 2. So you can use that for databases. Also, there are deployments. So here we used a stateful set, but there are also deployments, and you can use them when you want, for example, 3 pods, but want a shared volume, so that the volume is attached to all of the 3 pods. Of course, you would have then to use read-write many and not read-write once, and then it will also work. Yeah, thank you for listening.
Thank you very much, Dennis. So thanks for the presentations. Thank you, Antoine, Wouter, and Dennis, for the insights around the progress of Exoscale's SKS. In the meantime, we have received some questions, and we did because of the running out of time to answer them directly in parallel to the presentations. But the ones we did not answer in direct, we would like to ask in the panel. So Wood is just missing for his video. Here it is, perfectly. So one question which is open is directed to Dennis. And this is a question on Longhorn and its potential use for running a database in Kubernetes. You have mentioned its replication capabilities, but do you see this mechanism replacing the database own replication mechanism? How would you use Longhorn to build a database cluster in this respect?
So no, I don't see it replacing, but of course it depends on the exact database you use always. So for example, you could use a MySQL Galera cluster, and then I would configure it this way that, for example, every volume is replicated like 2 times, and then you have on top the replication of the database. So you definitely should do both.
So there's a second question. So you have the time to ask questions. We are trying to answer them in this panel. So now comes in, is it possible to encrypt the data stored in Longhorn volumes? Directed to Dennis, I guess.
Yeah, I think there is no out-of-the-box solution, so you would have to search for something else.
Thank you. So the next question is, how do versions upgrades work on SKS?
I can also answer that. So these are really simple. So you can either upgrade the master, and the master upgrade works without any downtimes. And if you want to upgrade the nodes, then you will just kill a node, basically, and Exoscale will boot up a new node with a new version. And that's the reason why I also presented Longhorn, because it's very important that you have something like Longhorn, so you can basically just kill nodes and they will then boot up with a new version.
Thank you very much. The next question is, does SKS run on Kubernetes?
Hey, good question, funny one. Yes, we nest the control planes we run for our customers on Kubernetes itself. And we actually, Pierre-Yves, our CTO, gave an interesting talk yesterday in a meetup. So there should be a screencast available of that soon, I guess, of our journey towards running Kubernetes ourselves and making Kubernetes, making SKS run on top of that.
Thank you very much. A new question is coming in. We use Longhorn, but have problems with rolling updates. Any tips for rolling updates and read-write ones? Since the volumes are used by one pod and you have to force delete it to deploy a new one without errors.
Usually you don't have to force delete it. So, but you must notice that Kubernetes has very long timeouts. So that means you need to wait until a new node is up. Then you need to wait for the timeout on Longhorn. This is hard-coded in Kubernetes. It's, I think, like 7 minutes. And after this timeout, Longhorn will try to basically restore the number of replicas, and then your pod should work again. But if you still have problems with this, you can also contact me afterwards, and then we can sort this out.
Thank you very much. Next question is, do you provide a registry service?
No, so
I'll take this one. Registry service, we don't provide this. However, we are working to bring container registry service to the marketplace. So hopefully we'll be able to talk about this in more details next time.
Thank you. What is the release policy and supportability for Kubernetes versions?
Yeah, our documentation will soon explain this. So the policy is that for minor upgrades, we always support the latest digits. So if we take 120.5 and you're currently running 120.2, 120.5 would be the recommended one. For the major releases, we have a support cycle of 180 days. approximately. So we always support the latest minor release from the previous major version, if that's clear.
Perfect. Thank you very much. So we are directly on point. So thank you to the speakers and the openness in answering the questions. Likewise, many thanks to our many attendees. A final note from my side, you will receive on Monday the addressed documents and the recording by mail. On that note, I wish you a pleasant rest of the working day and see you soon. Thank you very much.
See you. Bye-bye.
See you.